Alright, this lesson is on forms of the quadratic. So we're going to now use all the stuff we've learned before, and we're going to be able to show algebraically how to find all this information. Here we have a parabola, or quadratic. It opens downwards because we have a -3 here. And you can see here I've graphed it, and I know you can look at and find all this information by graphing, but you're going to show me all the algebra that you're going to do for each one. Now, we can find the vertex and axis of symmetry by completing the square. So these two, we complete the square, we can get that information. And you can kind of tell by looking at the graph what it's going to be. We can find the y-intercept and the zeros. Okay? The first one I want to do is the y-intercept. So let me see if I can get this to show while we do the y-intercept. The y-intercept is where it crosses the y-axis, and that is the point 0, a number. That's where it crosses the y. So if I put in the x spot as 0, so here's my formula. I got y equals -3, 0 squared plus 7 times 0 plus 9. You will see that we'll have a 9. So the point 0, 9 is where this crosses the y-axis right there. So this is the easiest one, is the y-intercept, because it's always 0 a number, and you put a 0 in for x and you can find where it crosses. Doesn't necessarily mean it's perfectly in the middle, it's just that's where it crosses. The other thing we know how to do here is the zeros. Okay, the zeros, here we can find this formula. So let me write it down here so I can see it better. So it's negative, let's write it here. So I've got y equals -3x squared plus 7x plus 9. Now if I want to find the zeros, I'm basically looking for the numbers that are a number 0, where my y's are 0. So here I'm actually doing 3x squared plus 7x plus 9 equals 0. I'm finding the x's, or my roots, or my zeros, that will give my y 0. Now by doing that, let's go back to where we were. This one, we can use the quadratic formula to do this. So I'm going to stack and rack a equals, b equals, c equals, d equals. And a is -3, b is 7, c is 9, and if I do b squared minus 4ac, I'm going to get 157 here. So I have x equals -b plus or minus the square root of 157 all over 2 times a, sorry, that's a 7, over -6. Now, don't need to worry about simplifying it. Just put this in your calculator because you want to see where it crosses, and it crosses at a -0.9217, and it crosses, if I put this with a plus and a minus, it would be at 3.2550. So there's my two zeros. So that's there. Okay, those two, you're like, okay, I can do that. Now we want to find the vertex and axis of symmetry. So in order to do that, we're going to complete the square and change it into vertex form. So let's start here. I'm going to write it up here a little bit more, and you can do it on the side if you need to. So the first thing we're going to do here is factor out the -3. So I have y equals, we're going to take the -3 out. So I have x squared minus 7/3 x minus 3. So what I did was I divided everything by -3. Now the -3 is going to hang out while we complete the square. So I have here x minus half the middle, 7/6 squared. What did we add that wasn't there before? Well, it was 49/36. We're going to subtract it. It's 4, sorry. And then we'll bring down our -3. So I have y equals -3, let it hang out here while we finish out, x minus 7/6 squared. And when I put -49 over 36 minus 3 in my calculator, I get -157. I can write here. It's -157 over 36. And then we're going to factor the -3 through, because we're done. So y equals -3, x minus 7/6 squared plus 57 over 12. That's a 7, right? So our vertex is, and I'm kind of running out of room here, you guys will have a space, but I'm going to put it on the side here. The vertex is going to be 7/6 comma, because you have to change the sign in the middle, and it's 150, excuse me, it's going to be, that's a 1, sorry, a 157 over 12. Okay, that's our vertex. Keep making a mess with this pen today. And our axis of symmetry is going to be x equals whatever our x number is, which is 7, 6. Now you can kind of look at this. 7, 6 is a little over 1, and if you can tell, it looks like the middle is a little over 1. So you can always check. And that doesn't look too pretty, but you know it's 12 something. It looks like that's where your turning point is. So that's how you find all that information from everything we've learned so far. Let's do another one. This one right here, I have y equals 2x squared plus 10x plus 17. We want to find the same four things. We want to find the vertex, axis of symmetry, which we can both do by completing the square, the y-intercept, which is the easiest, and the zeros. Let's do the y-intercept because that is a zero, a number. So wherever x is, you put a 0. So I have y equals 2 times 0 squared plus 10 times 0 plus 17. So that is the point 0, 17 that it's crossing the y-axis. And the zeros, what's going to be interesting here, it doesn't even cross at all. So let's see what happens when we stack and rack this formula. So the formula I'm going to write down here again because you can't really see it. It's y equals 2x squared plus 10x plus 17. And let's find our zeros or our roots. So we're going to use the quadratic formula. So I have A, B, C, stack and rack, D for discriminant. So you have A is 2, B is 10, C is 17, and the B squared minus 4AC comes out to be a negative 36. Now I don't know if you remember this from last year, but if it's negative in the radical, that means I don't have any real roots. So I got x equals negative B plus or minus the square root of negative 36 all over 2a, or 4. So this, remember, we can write this as 6i because it's imaginary. So I have x equals negative 10 plus or minus 6i all over 4, and they all can be divided by 2. So equals negative 5 plus or minus 3i all over 2. Now, you do have two roots here, but again, they're imaginary, so there's no real roots here. They're imaginary. So as soon as you see that negative for your discriminant or your b squared, you know it doesn't cross the x-axis, and it's kind of cool that you can see here by looking at the picture that it doesn't. Now let's complete the square to find the vertex and the axis of symmetry. I'm going to do it right up here, but you can do it on the side or wherever. So I have a 2 here, so we have to factor out the 2. We have x squared plus 5x plus 17 over 2. Okay, and then we're going to have the 2 hang out while we complete the square. X plus 5 halves squared minus 25 over 4 plus 17 over 2. So now we're going to combine these two. We have y equals 2 x plus 5 halves squared. And when I combine these two right here, I think we get something like a 9 halves if I can read my writing here. And then we're going to go through and multiply by 2. I don't think this is right here. And then we're going to factor it through. I'll let you finish factoring it through. I don't think I added those two correctly. So put those there and then multiply by 2. I do know the axis of symmetry comes out to be x equals negative 5 halves, which that part's right. And I know our vertex comes out to be negative 5 halves, 9 halves. But you fill in here the rest of this so that you can get those answers. Okay, so we found all that information. Now the next thing I want to show you is we can actually find quadratic equations just having information. And there's two forms that you have. Well, there's actually three, but the two that you're going to use the most is going to be the vertex form, ax minus h squared plus k. Please be careful. A lot of students and everybody will forget the squared. And the other one is the zeros format that I showed you before, or your roots, x minus, x minus. So let's look at this one first. You're going to use either one compared to. So if I have roots or zeros, I'm going to use this one. If I have a vertex, I'm going to use this one. If I have both, you can choose. So this one, they told us the vertex. So I'm going to, wait a minute, what are these? If you look at this, if it's a number 0, these also must be roots. So we actually could do this either way. So I'm going to show you this both ways. Either way will be right, even though the formula would look a little different. So let's first do the vertex form, because they told vertex. That's the first thing I thought of. Okay, now when you go to do this, all you do is you're going to plug in the information. So here's a vertex. If I take this vertex and throw it in the HK spot, what I end up with right here is y equals a x plus 5 squared, because when you throw that negative 5 in, it turns opposite, like we know, plus 7. So we're almost there. We just don't know what the a is, if it turns upwards or downwards. You can pick now, and like I always told you guys, if you want to sound smart, just say plug it in. We can actually pick either one of these to plug in. Let's pick the negative 7, 0, because 7 is my lucky number. So this is xy. If I plug the point in xy and solve for a, then we can figure out what the a would be. So in the y spot, I'm going to put a 0. I don't know what a is. In the 7, I can put negative 5. Excuse me, in the x spot, I can put negative 7. And then we're going to solve for a. Now when we solve for a is hooked to this. This is a term right here. You have to do this squared part first and hook it to the a. So I have a times negative 2 squared comes out to be a 4. So I'm just going to leave it like that so you can see it. So I have 0 equals 4a plus 7. Now subtract the 7 on both sides. So you have negative 7 equals 4a. A equals negative 7 over 4. So the formula for this quadratic, which is quite interesting, is negative 7, 4. So this opens downwards. And it's going to be x plus 5 squared plus 7. So that's one way you could do this. Say that could be the formula using those points, right? Now, because they gave us the roots and the zeros too, I can use it this way. Now, not all of them you can do this way, but I'm going to set it up here. Now, if you use the zeros or the roots, you have to put those in your formula first. So when I throw the negative 7 in here, and when I throw the negative 3 in here, they both turn positive. And if you guys remember, when you go to find roots, it always seems like it's the opposite sign. It's because of this. The formula has negatives in it. Okay? So I threw them in there. So now look what I have here. I've almost got the formula done. I just don't know what a is. So I've used the two roots. So now I'm going to use a vertex as an xy point and just plug it in. So I have 7 equals a. And the x is negative 5 plus 7. The x is negative 5 plus 3. So I put the x in there. 7 equals a. Now negative 5 plus 7 is negative 2. Negative 5 plus 3, excuse me, this is a positive 2. This is a negative 2. Now I have 7 equals negative 4a, or a equals negative 7/4. So the a is the same. It's just going to look different the rest of the way, because now I'm going to plug it back up in here. So I have y equals negative 7/4 in the a spot, and then it's going to be x plus 7, x plus 3. Even though that looks different, if you were to graph them both, it'd be the exact same parabola. We were able to do both of them. Okay, let's do a couple more. Oh, this time I have a picture. Nice. So I look at it and see what information they gave us. Did they give us zeros, or did they give us a vertex? And they gave us the turning point of the vertex, so I'm going to use the vertex formula. And that's the only one I can use in this case. So we're going to use the vertex formula only. So I have y equals a x minus h squared plus k. And we're going to put the vertex right in. This is the H and this is the K. So we got y equals A. Remember the sign changes. If I throw negative 3 in here, it's going to turn positive plus 2. Okay, we're almost done. Now we just have to find what A is. What I do know, A is positive because this is opening upwards. It's a smiley face. So it better come out to be a positive answer. So now we have another point. They gave us another one. That's nice of them. So here's an X and Y. So we can plug that in and find out what A would be. So in the Y we have 5. A in the X we have 0. So you have 5 equals A. And then 3 squared is 9. See how I do that? Make sure you do that first. Sometimes the algebra will mess people up, and I just want you to be careful. Okay, it stopped writing. Be careful how it works. So this is plus 9 plus 2. If I can get this to write again. Sometimes it's finicky. So now I have this. Okay, there we go. So I have 5 equals 9A plus 2. Subtract 2 on both sides. I have 3 equals 9A. Divide by 9. A is 1/3. Be careful. Don't go too fast. So now my actual formula here is y equals 1/3. And I'm happy because it's positive, because we knew that it had to be because it opens upwards. And then this is the rest of your formula. Box your answers. Let's look at another one. Let's look at this one right here. If you look at this parabola, oh, this one opens upwards, and see what information. Well, they gave us the y-intercept right here. This is the point 0.06, so that was nice of them. And then they gave us the roots here, or the zeros. It crosses at 1 and 3. So we're going to use the roots formula, or roots or zeros formula, whichever way you look at it. And so this is going to be like this. We're going to use y equals A, x minus, x minus. Now, this one's easy. We're just going to throw the roots in, so they're both positive, so I'm going to turn negative. So y equals A, it's going to be x minus 1, because if I throw the 1 in there, if I throw the 3 in there, there we go. Now we just got to find A, and I know A is positive again. They gave us this point 0.06, my xy, I'm going to plug it in there. So I have 6 equals A, 0 minus 1, 0 minus 3. So you put the same 0 in there. So I have 6 equals A. I have a negative 1 times a negative 3. 6 equals A times a positive 3. So here A, if I divide by 3, A is 2. So my formula really is y equals 2 x minus 1, x minus 3. And you leave it just like that. You don't have to multiply it out. So that's forms of the quadratic.